Okay, so the first problem we're looking at is asking for the positive solution of the equation x squared equals 2x plus 35. So what we need to do is start off by moving everything to the left side. We want to put this in standard form. In order to find the solutions, we're going to have to put it in standard form and factor. So we're going to take the 2x and move it over. And in order to do that, I'm going to subtract 2x from both sides. So I end up with x squared minus 2x is equal to 35. And then I also need to move the 35 over. It's a positive 35, meaning I am going to subtract 35 from both sides. So I end up with x squared minus 2x equals 30. Oh, not equals, my bad. Minus 35 equals 0. So now I'm ready to actually find my zeros. You can do this in several different ways. We can use the quadratic formula, we can complete the square, we can do all kinds of different things. The easiest thing that I think we should do at least is just set up our two binomials and find the two numbers that are going to multiply to give us negative 35 and add to give us negative 2. So I'm looking for factors of negative 35. That could be negative 1 and 35, 1 and negative 35, negative 5 and 7, negative 7 and positive 5. The two that are going to add to give me negative 2 are negative 7 and 5, meaning that my two factors, I'm taking my x squared, splitting that up into x and x, and then I'm going to use those two numbers, minus 7 and a plus 5. So I have factored it. Now, after we factor it, we're not looking for just the factored form, we're actually looking for the solutions. So I then need to take each of these and set them equal to 0. Okay, so then I'm just solving each of these, and these are one-step problems. So I get x is equal to 7. And for the second one, solving my one-step problem, I get x is equal to negative 5. Now the question did ask for the positive solution, and the positive solution is positive 7. For the second problem, the equation ax squared plus bx plus c is equal to 0. This said that which form is it in is basically what it's asking. Is this standard form or is this vertex form? So this is just knowing the form, and this is standard form. Okay, for the next one is what is the factored form of 9x squared minus 4? So this is actually difference of squares. There's something we should notice about this. We've got perfect squares our first term, a perfect square for our second term, and we are subtracting them. So we call that difference of squares, and this was just a formula. We set up two sets of parentheses, one plus and one minus. We take the square root of the first term. So the square root of 9x squared is going to be 3x. So that's going to be the first term in both of my binomials. And then I take the square root of 4. So the square root of 4 is 2. All right, so I just took the square root of 9x squared. That's how I got my first term. And then I took the square root of 4, and that's how I got my second term. And that's it. So that is my factored form. For the next one, I'm solving the equation. I want to know what the negative solution is. So for this, what we're going to do is just solve this like we were solving for x, like in a linear equation. Okay, so what I would do first is start by moving my 45 over. It's a minus 45, so I would start by adding 45 to both sides. So I'd have 5x squared is equal to 45. For my next step, I need to get rid of this 5. So I divide. I get x squared is equal to 9. And finally, in order to get x by itself, I get rid of the squared symbol by doing the opposite of squaring. I square root. The square root of x squared is x. And the square root of 9 is going to be plus or minus 3. So that means that it could be a positive 3, it could be a negative 3. The question was asking us for the negative solution. So for this one, we would have just put negative 3. Okay, for the next one, it says to use the discriminant to determine the number of solutions for the following quadratic equation. So the discriminant is b squared minus 4ac. And we label these across. The number in front of x squared is a, the number in front of x is b, and the constant is c. So I'm plugging these numbers in. So this will be negative 7 squared minus 4 times 3 times 1. And when I solve this, negative 7 squared gives me 49. And this is going to be minus 12, which gives me a final answer of 37. So it asks me to determine the number of solutions. So in order to figure out the number of solutions, I look at my discriminant. When the discriminant's a positive number, if the discriminant's positive, like in this case, that means that it has 2 solutions. Whoops, kind of running out of room here. Okay, if the discriminant is negative, that means it doesn't have any real solutions, no real solutions, 0 real solutions. And then finally, if our discriminant ends up being 0, it has 1 real solution. So in this case, I did get 37. That's a positive number, and a positive number has 2 solutions, so my answer would be letter B. Okay, simplifying a square root of a negative. So if I have the square root of a negative, I want to get rid of the negative under the square root. We can't leave a negative under a square root. It's just not possible for us to square root a negative number, which means that we're going to end up with imaginary numbers. So in order to get rid of the negative, I'm going to pull out an I. So there should be an I on the outside of our square root, and on the inside is just a 50 now. So pulling out an I gets rid of that negative symbol. And now I actually have to simplify that square root by checking to see if there are any perfect squares that I can divide into this number. So if we don't remember our perfect squares, we need to make a list. 4, 9, 16, 25, 36, 49, and so on. Okay, so for this one, the largest perfect square that can divide into 50 is going to be 25. So when I divide 25 or 50 by 25, I get 2. So the 50 can be split into the square root of 25 times 2. And we can actually take the square root of 25. The square root of 25 is 5. So 5i square root of 2 is our final answer. Okay, so the question's asking for the maximum or minimum value. So first we have to determine if we have a maximum or a minimum value. So if you guys remember from class, I said, remember Max? Max is a negative person. Max has a frowny face. Okay? This is Max, and Max is negative. That means that if we have a number in front of the parentheses that is negative, it's a maximum. When that number is positive, it's a minimum. Okay, so this is a minimum, and we just have to say where the minimum is. And it is at whatever our y value of our vertex. So the y value of the vertex is the number on the outside. It's positive 6. So the minimum is at 6. Okay, and then finally identify the vertex of the following quadratic equation. So if I want to find the vertex, there is a formula for that. Negative b over 2a. This gives me the x-coordinate of the vertex. It's also my equation that gives me the axis of symmetry. So I'm plugging in b and a. So remember, a is the number in front of x squared, b is the number in front of x, c is the constant. So this is negative 8 over 2 times 1, which gives me negative 4. So that's the x-coordinate. I still need to find the y-coordinate. To find the y-coordinate, I plug it into the equation. So y is equal to negative 4 squared plus 8 times negative 4 plus 15. So that ends up being 16 minus 32 plus 15. Okay, so y ends up being negative 1. So our coordinates are negative 4, negative 1, which will be letter C.